Okay, thank you everyone for joining me this session. And again, this is the second event for our TiDB user group, APAC. It's really happy to with you guys this lunchtime. Some of you are currently maybe have a lunch and already, hopefully some of you already finished. Because we are doing the APAC event, it's really across the time zone nowadays. With some friends also from Australia and also Japan coming to join us. Thank you so much again for your time today. Hopefully today's event is another fruitful session for you after your lunch. And again, right, today, some of you may enjoy a little bit Black Friday. Hopefully you already shop whatever, snap the shop deals, whatever you are interested to buy. Hopefully this lunch session is another session for you to gain from our speakers. So today we are really happy to invite all these speakers from Asia Pacific. Like Jing Ru is head of infrastructure from ShareIt, and also VP of engineering from Tokopedia, and Li Shen from PingCAP join us on the fireside chat. Dave and Carol from Square will talk about their stories about their adopting the technologies using TiDB. These are the agendas for today. It's a packed agenda. Absolutely leave some of the Q&A sessions for you to asking questions. So I'm Neil. I'm the TUG APAC ambassador. I will be the host for today. A very quick introduction before we jumping into the whole session. Because it's TiDB user group, we definitely want to reintroduce TiDB again because some of you may be new to this TiDB user group. So TiDB is an open source new SQL database supporting hybrid transactional and analytical processing. It has horizontal scalability, strong consistency, and high availability. And most importantly, it's MySQL compatible. So what is TiDB user group? It's a fully independent, self-organized nonprofit organizations focusing on the database and big data. So we bring the TUG to APAC, hopefully really to gather people and talents into this community. So personally, myself, I was engineering manager before. So when you look around, right, there's no big community focusing on big data and database throughout this region. So that's where we hope with the TUG coming and really can gather all of you together to discuss the cutting edge technologies. We together build a community, can really share with each other on the technical insight. And also some of you may want to come up and speak about your own technology insight. We are more than welcome for you to do that. So again, we have a channel for you guys to really communicate with each other. Scan the QR code, join the Slack channel, look for TUG-APAC. That's where our home at. And feel free to asking any questions for today's session or in the future if you have more questions coming up. For today's session, it's on Zoom webinar. So that's where you have another channel on this Zoom where you can just ask questions from Q&A. I see some questions posted already. Let me have a quick chat. Oh. Sorry, I see a lot of messages coming. Yeah, so really that's the today's I want to talk about. And this session, the first session will be from Li Shen, our VP engineering from PingCAP. We'll talk about how we build the scalable distributed database TiDB, because we're gonna discuss a fair chat on the sharding versus distributed database. So I think it's good really to understand more a little bit about that. And also more interestingly, like Li Shen is our second engineer for PingCAP. He definitely have a deep insight on how we really build this TiDB. So without further ado, Li Shen, I'll hand over the mic to you.
Okay. Can I share my screen or?
Yeah,
you can choose?
I'll stop sharing my screen.
Can you see my screen?
Yes.
Uh, okay. Hello everyone. Welcome to see my talk. And I'm Li Shen, VP of Engineering at PingCAP. In this talk, I will tell something about how we build TiDB, especially how we make TiDB a scalable database. First, a few things about PingCAP. PingCAP is a global company with global team, and we just finished our Series D funding raise in this month, and we are expanding our company to other regions like Singapore, Tokyo. Yeah, we already have offices in China and the US. Yeah, our company is founded in 2015, and in the past 5 years, we only focus on one product, that is TiDB. Yeah. TiDB is an open source distributed NoSQL database, and it's a hybrid transactional and analytical processing database which speaks MySQL protocol. Yeah, please note that TiDB is not a MySQL middleware or proxy. It's not a fork of MySQL, or it's not a SQL on Hadoop solution. We built this product from ground up. Yeah, there's the whole project is open sourced. There are 3 main projects. The first one is TiDB. In this page, I mean TiDB is the SQL layer of the product. You can see the GitHub repo. It has a lot of stars and contributors from all over the world. Yeah, it has more than 500 contributors for this project. The second one is TiKV. TiKV is created by PingCAP, and we donated this project to CNCF. Now it's the CNCF graduate project. And the third one is Chaos Mesh. It's also created by PingCAP, and we donated it to CNCF. It's a sandbox project. Chaos Mesh is the testing framework we use in PingCAP to test our distributed database. So if you have the requirement you have needs to test your own distributed system, you can consider Chaos Mesh. Yeah, now TiDB is widely used in many countries for a lot of users. You can see some of the logos here, but actually we have more than 1,000 adoptions, production adoptions. Yeah, so we can see it's widely used in in a lot of industries. Now I will go through our design goals and architecture of TiDB. As Neil mentioned, that we have 4 design goals or 4 key features of TiDB. The first one is horizontal scalability. As a distributed database, I think this is the first priority feature. With TiDB, you can easily add more instance to the cluster to support more traffic or QPS. And the scaled process should be transparent to the application layer. You do not need to use table partition or sharding in your application layer to get more scalability. And the second one is high availability. As a distributed database, there's many nodes in one cluster. So you may meet the situation that some of the nodes is unavailable. For example, you are doing a rolling update. Yeah, so we need to have high availability for the cluster. The third one is ACID transaction. Yeah, TiDB is a relational database. We should have transaction capability in this database to support the mission critical use case. For example, the core banking scenario. The last one would be the MySQL compatibility. Yeah, TiDB speaks MySQL protocol and dialect. Yeah, so if your application is already on MySQL, you can easily migrate it from MySQL to TiDB, and the syntax, the ecosystem tools that you are familiar with, is also available on TiDB. This is the high-level architecture of TiDB. As you can see that on the top is the TiDB, it's the SQL layer, it's the stateless SQL layer, and the TiDB or the SQL layer doesn't store data in itself. The data is actually stored in the TiKV layer, which is a distributed key value storage layer. And on the right side is placement driver. We call it PD for short. The PD stores the metadata of the TiKV storage engine and control the whole storage cluster to, for example, for load balancing or failover. Yeah, so this is the overall architecture. Let's dive into each layer. The first is the storage layer. Logically, you can recognize TiKV as a big map, a big key value map. The key is sorted by byte order. So logically, you can see that big map, and we split the key space into small chunks, and for each chunk, we name each chunk a region. Please note that the region I mentioned here is not geography region. It's just a concept we borrowed from HBase. Yeah, logically, a region is a small piece of key range. Yeah, for each region, we have metadata for the region. The metadata contains the start key and end key. Physically, for each region, TiKV will have multiple replicas to store the actual data, and the replica of each region is distributed among the TiKV cluster, and the data is actually stored in the RockCB instance embedded in each TiKV instance. So region is a logic concept, and the replica is a physics concept. And this is the architecture of TiKV cluster, and you can see that for each region we have multiple replicas distributed on different TiKV instance, and the PD cluster will store the region meta and provide the root info to the client. Yeah, there are some key features or key points for you to understand how TiKV could be a scalable key value storage engine. The first one is how data is replicated among the replicas. That's the answer is Raft. We use Raft as to provide strong consistency among over the replicas. And there is some concept you need to know that Raft has leader and follower, and in each Raft group, that's the read and write operation only go for leader. Yeah, and then the write operation will replicate from the leader to followers. Yeah. You can get more information about Raft through this website. And as I said that the region region is a small piece of our of the key range, and the region is split and merged automatically by TiDB cluster. You do not need to care about how the region size is maintained by TiDB. Yeah. When you at start point there's only one region, and when the data is inserted into TiDB cluster and the region size exceeds some threshold, for example, it's 96 megabytes by default, the region will automatically split it into two regions. Yeah, when you delete data from TiDB, the data volume in the region is too small. TiDB will merge the region into one region to reduce the region number, and in the most cases, the region split and merge is decided by the data size, and we have another feature for the region space is based on the load. Yeah, that means when the load on one region is too high, or the QPS on one region is too high, we will split the region into two regions to make the load more balanced. Yeah. So here is a simple example about how TiDB can scale. Yeah, you can see this example. For example, there's a lot of data on node A, and the disk is almost full. You can add another MP a new instance into this cluster, and the cluster will detect that the disk usage is unbalanced in this cluster, and will decide to move some data from node A to node E. And in this process, we use Raft to add one more Raft replica on the newly added instance. And after the replica is done, we will remove the replica from the original node A. Yeah, so in this way, when you add more node in the cluster, the TiDB cluster will do the load balance automatically. Yeah. When there is node failure, for example, the node E meets something like power off, the cluster will detect that node E is not here. Yeah. So after timeout, it's 30 minutes by default. The PD or the cluster will add another replica to the cluster to make sure that there's enough replica for each region. So in this way, the cluster can be self-healing. Yeah. Yeah, that's the introduction about our storage layer. And on top of the TiDB storage engine, TiDB is a key value storage engine. We build a SQL layer, which name is also TiDB. In this section, we name it the tidb-server, which I mean the SQL layer. Yeah, this graph is the architecture of our SQL layer. You can see that it's do a lot of things about SQL or query, and it just speaks MySQL wire protocol to the client. So client will interact with TiDB instance. Yeah. So you can see that our TiDB server or SQL layer is a full-featured SQL layer. It do the query parsing, optimizing, and send the request to TiDB and get request back and compose the result package to the MySQL client. And we build our own cost-based optimizer in TiDB or in the SQL layer that can handle not only OLTP query but also complex OLAP query. Yeah, and we support some features like secondary index and online DDL. Yeah. TiDB is a key value storage engine. The TiDB will translate the relational model or relational data to key value pairs. For example, for each row and each column or each index, TiDB will compose the data from the original insert statement to the key value pairs and submit the key value write operation to TiDB. And when you so the data sharding, so data sharding is done in the key value storing engine. The SQL layer or the application layer will not notice the data sharding. When you want to query data from TiDB cluster, and the SQL layer will pass the query and do the query optimization, generate the best query plan it think. And the query plan would be split into two parts. The first part will execute in the SQL layer, and the second part will be pushed down to the storage engine. That is the TiDB instance to run on the coprocessor module or in TiDB. In the coprocessor module, the coprocessor is also a concept we borrow from HBase. In the coprocessor module, TiDB will use the query plan get from the SQL layer to compute to get the data from the local RuxDB instance and generate the partial result and send it back to SQL layer. The SQL layer will get all the results from multiple TiDB instance and to get the final result, then send it back to the client. That's a simple example of how TiDB or the SQL layer writes data and runs the query. TiDB is a MySQL compatible database. So if you are using MySQL already, we provide some tools for you to migrate data from MySQL to TiDB. We also provide to migrate data from TiDB to MySQL. So if you are with the, for example, with DM, our migration tool, you can generate you can get the MySQL bin log from upstream MySQL. So a DM acts as a MySQL slave to get the bin log from MySQL upstream instance and inserts data into TiDB cluster. And we also provide bin log service in TiDB cluster, which means you can get the data change from TiDB cluster to and push the data change to the downstream. So in this, with the ecosystem tools provided by PingCAP, you can easily migrate your existing MySQL application to TiDB. And it's also possible to migrate the data from TiDB to MySQL back. Okay, here's more information about PingCAP. You can follow our Twitter or join our Slack channel to discuss more things. Thank you.
Thank you, Lishan. We didn't really have a planned Q&A session because Lishan will join us for fireside chat. But we do have a question for you, Lishan. I feel it's good to answer directly since the audience is asking very specifically on your presentation. Let me pull out the chat. So the question is from Sky. What if a node or coprocessor failed during the query execution? Does it retry or recover like a Spark or just fail directly like a Presto? Did you get the question?
Sorry. The line is not good. Can you repeat this question?
Oh, can you hear me now?
Yeah, better.
So the question is, what if a node or coprocessor failed during the query execution? Does it
Okay, so
retry or recover like Spark, or just fail directly like a Presto?
TiDB will retry. For example, send the query to TiKV and process the query to TiKV, but doesn't get response in some time in a certain timeout period. TiDB will retry the query.
Cool, thank you. Hopefully that answers your question, Sky. Thank you so much, Lishan, again. So we'll wait for a while and after you coming back to join us on the Fireside Chat. So our next session will be with Dave and Karel. They are from Square and the Cash app. For me, I personally really has been eye on the Cash app because their growth in the past year is really tremendous. It's really honored to have you, Dave and Karel, with us to talk about your journey, technology, kind of architecture, and also the journey with TiDB. So with that, I'm going to hand over the mic to you, Dave.
Okay, great. Thank you. Hi, everyone. Thanks for having us along. We'll get kicked off with a couple of quick introductions. So my name's Dave McPherson. I'm an engineering manager in the Cash Cloud platform group. Within that, I look after a couple of teams, the storage team and also the developer velocity team. I've put a couple of ways to get in touch with me if anyone's interested as we go along. And my colleague will introduce themselves as well.
Hello, everyone. I am Karel. I am a cache engineer, a software engineer. I've been working in cache for the last 3 years, mostly focusing on scalability of databases. And you can reach me at LinkedIn, Karel-Alfonso.
Great. So we thought we'd actually start with what on earth it is that cache actually is. For most folks, it's not available. It's only available in the United States and the United Kingdom at the moment. So we thought we'd just sort of give you a little bit of a rundown on what it can do. So it's effectively a mobile cache or payments kind of system. You are able to do quite a number of things from direct deposits of money into it, similar to a bank account. You can get your own physical card, and you can get that in a variety of colors. You can even then do some pretty designs within the app itself. It lets you actually use your finger and create some interesting designs, which has led to some fairly interesting cards being created that are quite unique to the individual. Within there, you're able to buy and sell Bitcoin and also trade stocks as well. So something worth noting is you're able to trade dollar share or dollar portions of shares. So even if something's worth $800, you can take portions of it, which really feeds into sort of the whole concept and ethos of Square, which is to put financial tools into the hands of those who are more disadvantaged than others. So what's all that meant for Cash App, and in particular, our infrastructure and storage systems? Well, we've had what a lot of lovely people like to call growth up and to the right, and it's really lovely. The accountants love all of that. But what does that really mean for infrastructure engineers or platform engineers like ourselves? So we had a really lovely on-prem, because Square as a company actually predates the cloud. And so we had a lot of our on-prem data store in our original system. And so that was all fine. We just, as the load kept on going, we'd make the database a little bit bigger. And then, you know, things got a bit bigger and it got a little bit bigger again. And it was all going well. And then, oh my goodness, it was getting really, really, really big, and it wasn't going so well. So we ended up approaching these problems with a bunch of the usual approaches that people take. So things like putting in a large database. So a large database is great, but as a lot of you would be aware, and if you're not, you're about to find out if you ever scale, it doesn't scale in a linear fashion, the costs anyway. So when you go to a bigger database, it costs an extraordinary amount more, and you actually hit an endpoint in a number of directions. We were a little bit constricted in the sense that our system was effectively 3 monoliths pointing to 3 separate databases, which sounds great because you share the load around 3, but the reality was that all 3 were getting hammered as well. The way our queries were put together I mean, in truth, Cache had spun out of a Hack Week project. And so a lot of the queries were not particularly well optimized either. Anyone who's been a database administrator or DBA knows all about those dastardly engineers and their terrible, terrible queries, particularly when you wrap an ORM in there as well. So we started trying to do things like break up the app, breaking it out into separate services, each of them with their own systems that, hold on, I should have turned off my notifications. Each of them with their own database as well that feeds through. And that's okay-ish. And then we also moved into using a tool or an approach or a system, an open source system called Vitess. So Vitess effectively wraps over the top of MySQL and allows you to create shards, which is great, really, really good, and certainly solved a lot of the problems that we had, particularly within our on-prem data centers as well, where we were able to actually install Vitess onto the actual instances that were running the MySQL daemons and work it from there. But one of the problems that we got was, that is a built-in feature of Vitess, is that the transactions aren't ACID. So you can use things like two-phase commit, and the authors of Vitess even themselves recommend that you design it so that you don't actually have to use two-phase commit, which effectively removes ACID from that suite. Now, that might be okay when you're building an application out from scratch, but when you're retrofitting an application back in, it does become quite difficult. So it was going to require some fairly major refactoring of our application. Things like cross-shard transactions being either removed or managed and handled in a way that was less onerous on the system. This was very challenging. Every model in our system ended up having to require a shard key. Foreign key changes also had to occur as well. So the application had to become quite aware of the shards in order to avoid cross-shard transactions, which were very expensive, and actually was the main candidate for that non-ACID activity as well. So that was great. So we ended up with Vitess and sharded MySQL instances, and we started exploring getting it up onto the cloud because Cache continued to grow. And to sort of give you an idea of where we've ended up now, from a little Hack Week project, we're now in the realms of 30 million monthly active users. We've got around 90% year-on-year growth. And anyone who's dealt with growth like that recognizes that it becomes very difficult to get ahead of the curve. You're constantly firefighting. You're often battling a lot of outages and things that break literally just under the heat of the number of folks coming in. As it turned out, COVID was a major kicker for us, as well, as we were able to pivot and work directly with the federal government in the United States and allow people who didn't have access to bank accounts in the United States to get access to the federal COVID funds directly into their Cache apps, which was a great win for them and us, in the sense that it brought a lot of money into the ecosystem. It also brought an awful lot of traffic. So at the moment, in peak times, which is typically sort of Friday afternoon and Friday evening in the United States, and because that spreads across the continental United States, it really spreads those time zones. It means a good 12 hours on Friday. We're running at a very high load. Some of the peak queries per second can be around 2.5 million queries per second. Is a problematic metric, but regardless, the load is pretty high. At any given point, we've got around about 100 terabytes in transactional storage, quite a large number of shards wrapped over the top of about 1,000 different database instances. So that's sort of where we're at now. We were trying to move out into the cloud, which would allow the applications themselves to continue to grow more exponentially. We started to run into problems with Vitess, particularly in the cloud, and particularly with the decision that we made, which was to wrap it over the top of Aurora. So pro tip, maybe reconsider that. At this point, I'm going to hand over to Corel, who will carry on and discuss how we progressed from effectively Vitess, moved into the cloud, and have piloted out TiDB. Corel, over to you.
Thank you, Dave. Yeah, so in our case, as Dave mentioned, we were quite successful in managing to scale inside the data center with Vitesse, but there were still issues. As Dave explained, Vitesse across shards doesn't give you, or at least we weren't using the two-phase commit approach that they provided. I think at the start it wasn't at a mature state, so we were using best effort transactions, and in the cloud we wanted to have a solution that was ACID compliant with minimum changes to our data models. We also found out, the decision of wrapping Vitesse on top of Aurora instead of MySQL instances, which is what we had on premises, it didn't work as well, just because we needed to do certain types of configuration on top of Aurora that sometimes weren't compatible. We needed to manage parameter groups, and it wasn't as straightforward. We also found that, on premises, most of our product engineers have to have strong knowledge of the fact that the database that we're working with was sharded. And this implied not only configuring the sharding tables that they were using in their applications, but also knowing the type of queries and whether it was going to lead to cross-shard transactions or cross-shard queries, which were in certain paths that were of high load, a problem. We also wanted easier global indexes, which Vitesse provided that as well. But for us, we required at times to backfill the secondary indexes. It also had to be configured as well. So we wanted something that out of the box would give us that. Another issue was a capacity. How do we scale as we go? And in Vitesse, it's awesome. You can trigger a shard split, and you can split a shard into multiple databases, but you have to trigger that manually, but also you have to provision those databases by yourself. So there's a bit of overhead from an operational perspective in the process of scaling. We never tried merging shards. It's also a functionality that was provided. And on top of that, we were deploying all our services on Kubernetes. We wanted to be cloud native, having all the observability things in place to understand how our systems were performing. We wanted also all the self-healing capabilities that you get out of Kubernetes. So we need to explore how do we keep doing this and improving what we're currently doing. Next slide, please. So we were already aware of TiDB. I think it came up, when TiDB was starting as something to watch out for. And we decided at some point to look at the state of TiDB and give it a go. We were particularly interested in the fact that it's a NewSQL database, NewSQL from the point of view of the global scalability. It's MySQL compatible, which is where our expertise lies. The fact that it's a hybrid transactional and analytical database, it was also quite interesting for us. So it's something that we wanted to explore more. But the most important factors were it was ACID compliant. The sharding is automatic, so we didn't have to trigger or provision new databases to do the shard splits, which was very time consuming. And you get global indexes. You can scale and shrink the cluster automatically as well. So we were happy to give it a go. Next slide, please. Just to refresh, I know Lishan already introduced from a technical point of view, TiDB. And I just wanted to show that for us, it was another big distributed system and something that we needed to learn. So we needed to get quite familiar with it. Just to refresh, you get application talking to a SQL layer, and you also have a storage layer, which is TiDB, and everything is managed by the placement driver, which is the cluster controller and manager. Next slide, please. So we needed to decide how are we going to roll this out, and it's not trivial given that we had already quite a bit of experience rolling out Vitesse on premises. Both projects, the biggest one took around a year or so. We wanted to be careful with the product that we would choose to do this. So we decided to choose a service that had low customer impact. The latency requirements weren't that high also the availability. And we picked this service. So it's a service that consumes asynchronously events from a topic in Kafka and publishes asynchronously to another service. So there's no customer interaction there. Next slide. So we decided to run some experiments. The first thing that we did was run load tests, benchmarks, just to get familiar at the start with the tool. This service that we chose, decided to set it up in a way that will consume from Kafka, taking shadow traffic from real production systems. So in this way, would allow us to understand how this system will, when we decide to roll it out to production, what's going to behave. So let me show some of the learnings that we got from running this particular service in shadow traffic mode. Initially, we set this up in Kubernetes using EBS volumes. We have the option of using local SSDs, but we went with the option of using EBS because these are persistent volumes that survive across crashes. And we decided also to start with GP2 volumes, which it's a volume in AWS that gives you IOPS based on the size of your volume. And decided to look into that just to look at the performance that we will get without having to incur into much cost. What we learned is that we didn't get good performance from using GP2. We're going to talk down the track further what is being done to improve it, but we decided that to explore using IO1 instead. With GP2, we were constrained on the bandwidth in the volume. We were initially looking at IOPS, and that was a bit of an oversight, but you also constrain in your volumes by the bandwidth, the number of bytes per second that you're receiving. So we decided to use IO1 because you have double the bandwidth, and also you can provision whatever number of IOPS you require without having to depend on very large volumes. Next slide. Yeah, so in terms of the way TiDB shards the database, or TiDB sometimes says no sharding, but there's some sharding happening in the background because the data is distributed across nodes. All our services on premises are using MySQL, and all of them use auto increment. And I don't know if it was covered before, but when you use auto increment, the way TiDB shards the application using range-based sharding, it can create hotspots or hot shards if the write path has very high load. So we did run into this in some of our experiments because some of the services that we're planning on moving towards TiDB are synchronous RPC-based services that will have a higher rate of writes. And even this service that is taking shadow traffic in the future is going to consume from more topics that could have even higher traffic volume. So with auto increment, you can end up with hot shards, meaning that one TiKV node will get most of the writes. Even when there's some balance, region, there's a scheduler that is going to balance the regions and move the data across, but you can still, based on the load, get a hot shard. So if you're planning on using this approach, I think my advice is to run your own benchmarks for the particular workloads that you're trying to put into production and decide from there. Next slide. So TiDB, at the time, we're using 3.something version, and there was this option using auto random, which was experimental. And I think since version 4.03 is now available, so it's not experimental anymore. And what it gives you is, on the write path, it balances out the primary key IDs across all the nodes in the cluster, which is very great. It's good for the write path. The problem is what happens now when you try to read the data. Next slide, please. So we found, for instance, that reading from secondary indexes of key. Let's say that we have customer and payments, and payments has a customer ID. So payments has its own primary key, which is distributed or random. And now we want to find certain amount of payments for a customer. Because it's auto random means that all the payments for the customers are distributed across the nodes, which means that we need to do like a full cross-site query. What we found is that for some plans, these created suboptimal execution plans. We've been talking to PingCAP. There are some documented issues in these slides that track some of the problems that we ran into. But we did hit issues because of this situation of using auto-random. So it set us well on the right path, but in the read path for certain types of queries, it was a problem. Next slide, please. So we discussed with PingCAP, and there was I think like a brainstorm. These are not easy to answer solutions because we're in the presence of range-based sharding, which means that you shard based on the key range, and we came up with in the discussion the idea of using clustered indexes, which is prefixing the primary key, or essentially having a concatenated key where you have, let's say in our case, we want to shard, and this is how it was in Vitesse, we want to shard by customer ID, and using clustered indexes, we can redesign the payments table, for instance, to have the primary key of the customer ID plus the payment ID. And in that way, if the index is clustered, we can have a situation on the right path where most of the rows for a given customer are in the same shard or the same region. And I'm loosely representing a shard here as a single, database, but in one single TiDB node, you're going to have multiple regions, which is the term for a shard in TiDB. But this is just very simplified. But the idea is that you want to have most of the data for your query access pattern to touch the least amount of servers or nodes. And this is a proposal for which there are issues already created in GitHub for that. Next slide, please. So let's have a look. We learned a lot through the months where we were deploying this traffic, this service using shadow traffic. We tuned the system and the configuration. I want to run you through what it looks like now from a metrics perspective. Next slide. So this is the application that is consuming from Kafka. And as I mentioned before, for us, the latency, even if it was in the order of seconds or tens of seconds, it wasn't a problem. So you can see, we managed to fine tune this so that we get in like 300 milliseconds. And this is for acknowledgement of messages to the topics, fetching, redeliveries. And we're currently consuming 1.4 thousand events per minute. Next slide. On the TiDB layer, we deployed in Kubernetes. Like I said, we have 2 TiDB nodes, 5 TiKV nodes. You can see the specs in there. Our traffic peaks during the day are currently consuming like close to 4,000 QPS, queries per second. As you can see, the P99.9 percentile for statement duration remains mostly under 500 milliseconds. We do get some load, and I think in this graph is the TiDB nodes, something we need to fine tune. Next slide. In the storage layer, and this is the EBS volumes, currently using IO1, so you can see we have like 20K IOPS, and the bandwidth is like 500 megabits per second. That's the default that AWS gives you. As you can see, we have like very low latency, mostly sub-millisecond latency in EBS volumes at the moment. And we're not fully using the capacity of the IOPS that we have provided, as well as the bandwidth. Next slide. So if I were to summarize, there are tons of things that we learned. There are lots of issues that we talked to PingCAP and that have been fixed. But I just, in the context of this presentation, wanted to highlight the main ones from our point of view. We wanted more performance from our EBS volumes. As I mentioned before, we noticed that we don't fully utilize the IOPS that have been provisioned, and as well as the capacity. So there are some issues that are being tracked to improve on that. We also want collocating rows. So realize that regardless of, you can use range-based sharding because it gives you, for the type of sessions that you do in online transactional processing databases, it works really well, but you want to touch the least amount of nodes as possible, and collocating rows for certain query access pattern is still something desirable. There's an issue that is being tracked for that as well. We've been, wanting to call it out, very, very extremely happy with PingCAP support. We have day-to-day conversations and fixing issues. The turnaround is really quick. We've also contributed to the open source project, and I encourage everyone to do so as well. And we were also happy with database migrations. One of the problems that we're having, even with Vitesse and Aurora, even without Vitesse, is that when your database grows really large, running online schema changes takes forever. So if you have 1 terabyte database, then you're already getting the limit where you can do an alter statement and add a column or modify something. So if you need to rebuild the table, it takes forever. And in TiDB, it uses a protocol or an approach from Google. I think it's called F1. And most of the database migrations or line schema changes are applied on the spot, except if you are adding an index, which can take a couple of minutes. Next slide. So everything is awesome. So we're very happy with, we had it run into the expected issues. It's a brand new system, but we're very happy with TiDB where it's at. Next slide. I just wanted to give you, from an engineering point of view, my personal view on TiDB. For us, the journey is like you would expect. It's a fully distributed system. I like to sometimes show this quote from Leslie Lamport, who is a renowned academic in the distributed system community, where he says, you have a distributed system is one which a computer that you didn't know existed, can render your computer or your whole system unusable upon failure, and could be a computer or a process. And we saw lots of that. We saw sometimes scheduled backups killing the balanced region scheduler, and then it doesn't come back up again, which means that you keep putting traffic, and then all of a sudden your cluster is unbalanced and things like that. So it's been a whole, learning experience for us. We're very happy with the maturity of the product, despite all of this. It's a fully usable database. All the Kubernetes support is awesome with the TiDB operator. So we're using that with all the Helm charts with some configuration on top of that. TiDB gives you very rich set of observability metrics. It's like sometimes initially, when you don't know the system, you can be overwhelmed by the amount of those. And as you start learning the system, you start getting more familiar and understanding which are the metrics for different types of situations that you have to look at. So in our case, the way we've approached this is we've been very, disciplined, to document in our runbooks every single learning, every single issue, and also document the metrics that are relevant in that case. So I encourage everyone doing that to follow that. Otherwise, it's too much information. There's quite a bit to learn. And as I mentioned, the database migrations, which has always been an issue for us. That's why we in Vitesse or in Aurora, we say once you get to 1 terabyte, you start thinking about sharding. Currently, we have 2 terabytes in our configured in our hard drives for TiDB, and migrations is not a problem. Next slide. The other thing for me, for being part of or dealing with PingCAP and the open source community, I'm really happy with the support for us as a customer, the awesome service. that we're getting as well from the company, and all the quick turnaround for all the issues that we're coming up with. And the TiDB documentation is excellent. Personally, follow the blogs as an engineer outside of Square. If you want to learn about distributed systems and some of the challenges, by all means, I encourage everyone to read the blogs. Next slide.
Thanks, Karel. So yeah, I wanted to second that as well. The support from PingCAP has been phenomenal, and you really will be a better engineer if you read a lot of the blog posts, which is a rare thing to say with a lot of vendors. So we are actually hiring at Square, and in particular within Cache. We're using, as we've been talking about, the distributed database TiDB. We've got Kubernetes. We use a lot of Go in our stack as well. Our teams are pretty distributed, so we've got quite a number of offices around the world. Or if you look around you at the city that you're in, that might well be where our next employee is sitting. So please, if you're interested, reach out. There's a couple of good ways to get in touch with me. And then we've also added a couple of references that we've been using across our slides and things that we've leaned on a lot in the past. So you get access to those through the slide deck. And if there are any questions, I'm not sure what was happening here, Neil.
Yes, hi Dave, Karel, it's a very good question, presentation. Thank you so much for the time. We do have a question, and it kind of follow up your question on your ending, where William is asking whether Square has any like intern opportunities on TiDB.
All right, we are looking at, so there is an internship program that's typically run out of the United States. We're looking to bring that into Australia as well. And we're also looking at using an apprenticeship model as well for those that are not affiliated with a specific university or college. So definitely reach out if you're interested in something along those lines. We are looking at implementing ones to feed into the platform team as well, not just the generic software engineering product engineers.
Nice. So any other question from the audience? You feel free to submit to the chat. We can answer directly to you. Yes, there's one more question coming up. The question is, so what's the key point for your data architecture you would like to address in the next 6 to 12 months? How will that impact the response to the business demand?
Do you have anything on that one, Karel?
Yep, sorry, I was muted. Sorry, could you repeat the question again? What is our roadmap for the next 6 months?
Yeah, so what's the key point in your current data architecture you would like to address in the next 6 to 12 months? And what's the impact to your business?
I see. So I think, you know, for us, I mean, architecture is very broad concept and it spans multiple systems that we have, but I guess the question was directed, I don't know if towards TiDB, but I tried to put it in context. You know, some of our services, the most critical ones that are constrained by scalability and load, we would like to migrate them to the cloud on TiDB. So that's where most of our focus will be in the next 6 to 12 months. This service that I presented on is been leading the way for us to get more maturity in terms of operation and learning TiDB. But yeah, in the next 6 to 12 months, we'll be putting in place systems that are gonna be more challenging for TiDB, you know, in terms of latency requirements, availability, you know, storage size. So we will see. What I noticed is that we've been learning already by doing experiments on that system on TiDB a lot, and it's been driving some of the issues that we found and that we've been working with PingCAP to solve.
Nice. Thank you so much for the presentation. We are almost kind of ending this session, but somehow there's another question from William, like a Cash App in the US. Cash App may be the first big company using TiDB. How Cash App find TiDB and decide to use it?
I arrived after that decision was made. Were you there, Karel, for when that arrived? My belief is that one engineer researched and presented
Yeah,
on it.
exactly. I mean, we realized, you know, I was part of the engineers that also sharded some of the on-premises systems and also provided a solution for VTest in the cloud. But we wanted to find a solution, like we said, that didn't require sharding. And I think I mentioned, but you know, some of us were already aware of TiDB and decided to take a closer look at it. Especially some of the recent presentations in Percona, you know, talking about no database sharding, anything that said no sharding required already captured our attention, just because of all the issues that we were having. So that's how we found out about TiDB. And I think, you know, we have this approach where if there's a tool out there, you know, especially if open source and it's a good community and we can trust, we're happy to explore it. So that's what we did. And that's how we find ourselves in this journey now.
Nice.
Yeah.
Thank you so much, Dave and Karel, for your time, and have a good evening and enjoy your weekend. So we'll switch over to the panel discussion now. So you can switch off your video now. Nice. Okay, I hope everyone can see my screen. So we are a little bit behind the schedule, which is expected. We are coming to the fireside chat session now. We're gonna discuss the database sharding, which you have been here a little bit from Dave and Karel already. And we're gonna definitely do some comparison, like versus distributed database, what's the pros and cons with that. And today we are very honored to invite Manoj, VP Engineering from Tokopedia, Jinru, the head of infrastructure from ShareIt, and also Li Shen from PingCAP. So I'm not asking them to share their video now, at least we can see their face. Nice. Yeah, so before we come into this session, right, I just want to make sure we are on the same page of this database sharding, because some people have a different understanding. These are for the benefit of the audience and also for the panelists when we discuss this. So a little bit brief background on database sharding. So traditionally, if you are scaling your applications, the database has to scale correspondingly, right? So there are two ways of sharding, which is horizontal partitioning, where you pretty much separate all the table rows into multiple different tables. And that's where you can put the tables to different instances to scale. There's another way to do it, which is vertical partitioning. Basically, you separate the columns into different partitioning, and you scale from there. There's a pros and cons with that. That's where we're gonna listen to the speakers and talk about this. From application layers, in order to cater to this sharding, there are two ways to do it. One is application level, you have to change the application to adapt to the sharding. The others, there are solutions also like proxy, like middleware, where it's a built-in to do the sharding, so that maybe there's less frictions in terms of application integration. Yeah, with that very brief introduction, I'm gonna stop sharing, but show the face of our panelists. Thank you again, Manoj, Jinru, and Li Shen to join us. So maybe to kick it start, we would like to ask each of you to introduce yourself. Manoj, maybe you can start from you.
Is it me to start, Neil?
Yeah, please have a brief introduction of yourself and the industry you are in, and also like why you are here. Just kidding.
Sure. All right. Thank you, Neil. I think it's great to be part of this panel discussion and meet you, Li Shen and Jinru. So I'm Manoj. I'm a VP of Engineering at Tokopedia. Tokopedia is a leading C2C, B2C, and digital marketplace in Indonesia. I'm responsible currently for entire PG marketplace. So when I say PG marketplace, what I mean is the entire shop, product, categories and seller platform experience on Tokopedia e-commerce marketplace. I've been with Tokopedia for last 4 years, and during that time, I've been lucky to participate in a lot of architecture and scaling the systems over time as we grew. Today, we are handling more than 9 million merchants on our platform, with more than 300 million product listings on the platform. That makes us one of the largest marketplaces here. And with those artifacts, we are actually serving more than 90 million monthly active visitors on the platform. So all that means actually large scale and a lot of data. So I think I'll be able to share my bit here as part of this panel discussion. Prior to Tokopedia, I was working with Adobe, where I was part of and have been leading development teams on digital imaging as well as the analytics side of the world. Yeah, that's a brief introduction here.
Yeah, Jinru, how about you?
Hi, I'm Jinru. I'm with Shareit for like around 2 years. Shareit, so I'll first give a very brief introduction of Shareit. Shareit has like several hundred million users, daily active users around the world. So it's a platform that provides global users with high quality digital content. So it's like a PGC app. So I'm here building the infrastructure team, and before Shareit, I was with Facebook and Pinterest for like 7 years, working in the infrastructure side. Yeah.
Yeah, Lishan already introduced himself. You can save the time.
Yeah.
So yeah, thank you so much for introduction, guys, and really great to have you on this panel. Things we are talking about the sharding and the distributed database. You may or may not study the distributed database. That's why we have this channel and panel and the debate. But my question to you guys is like, what's the business scenario currently do you need to face in terms of the choices of database sharding and distributed database? Maybe we can start from Manoj.
Sure, Neil. So I think in general, as the data size grows beyond what can be stored on a single node, and as the number of users on the platform scale, it is inevitable that you will actually be faced with this choice, right? So in our case, also, I mean, the same thing happened, and the precise reason behind it is that so there are some inherent limitations of hardware, right? So a single node will be limited by the number of CPU cores. It will be limited by memory. It will also be definitely limited by read and write IO that it can process within a certain time, right? Of course, I mean, storage technologies actually have evolved over time, but still those limitations exist, right? So all these together actually put the limit to the throughput that your database can process, and that's a key criteria for any database, right? And that is where you actually start facing issues like higher latencies or maybe higher error rates and so on. So in Tokopedia's case, I mean, so we are a microservices or basically service-oriented architecture implementation, and where we faced most problems were with order, which is a huge database, product, which is a huge database, and there is a transactions, which is a huge database, right? So all those three so they are already very big, and they have been growing at a very fast pace. So we faced these challenges in the context of that, right? Now there, as your title talks about, either you basically go and partition your database, which is sharding, or you basically go towards a distributed SQL database, right? Which are getting more and more popular, and there are more and more choices out there. So let me share a story for Tokopedia, right? So last year, our order database running on PostgreSQL was running at capacity, right? So the result was that the order management pages, which is both buyer order management as well as seller order management, they were running very slow, right? So I mean, the load time will be very high, the latencies are running very high, and in my opinion, it was basically a technical debt. We did not attend to it for a long time. So what happened was that, I mean, whenever their latency is higher, we basically, instead of attending to it, we basically try to solve it in a product manner that let's reduce the number of things that a user can query. And in the end, basically for some of the bigger sellers, we found that they cannot fetch more than 3 months of data. And that is the behavior that we go and build for them, right? And if they want to actually query more than 3 months data, for example, some sellers want to get a yearly report and so on, they need to download an Excel sheet or something like that. Now, that was not the right solution. So right solution was to approach the problem head on, and basically, finally we had to do, right? So the attempt was basically, can we actually shard it properly? So in the older Postgres versions, I mean, there was no native partitioning support. But thanks to Postgres 11 and onwards, now they have the partitioning support. So we went with that, right? So we basically sharded. Now the challenge here, and maybe I'll just take a moment to actually answer that. The challenge here was that, I mean, so sharding actually has to go hand in hand with your query patterns, right? I mean, for example, in buyer's case, I mean, he wants to find my last 100 orders, or right, or my last 2 months orders. But in the seller case, he wants only his shop's orders. And so you need to actually maintain two different kind of replicas with different partitioning from that original table, right? So that is what we went with. One was partition on the time, and the other was partition on the shop ID. And with that, I think today, I mean, if you open Tokopedia's app, and you can actually browse through years of data, and it's very fast, very responsive, and so on. So distributed SQL is something that we are assessing at the moment. We have earlier used Cockroach for transactions database, and we have been running it successfully. But we are also assessing more and more options now on distributed SQL side, and that seems very promising. Yeah. Hope that answers your question. Maybe.
Yeah, for sure. We're gonna expand that a little bit soon. So, Jinru, how about you? When do you face the choices of distributed database versus sharding?
Yeah, I think Manu has make a lot of points here. So I think we have a similar situation here. So since we have a lot of users, as shared, we have several 100 million users data. So it's impossible to store all this data in a single node. So we have to do sharded database. So that's why we will shard our MySQL database. We shard by the user ID. So that's the main scenario. So we have also other scenario that we need to shard DB, like we have a big data Hive table. Hive table, we have a middle store. Middle store, sometimes the data can become very huge. So in this case, we need to use the sharded DB to store data and serve the queries. Yeah, that's basically the typical scenario here at Sherrit.
Nice. So actually, my next question is following up questions on what you guys just considered, because while you are scaling the applications, and what kind of the considerations and procedures you guys will take as a technical leaders in terms of bringing the new technology stack and products into the company? This is for both of you, Manoj and Jinru, because you guys mentioning specifically, especially Manoj, you are mentioning like you're gonna evaluate the distributed database nowadays with Cockroach DB and potentially, hopefully, TiDB in place. What are the considerations and procedures internally you take in order to take this new technology stack forward, which may be bringing a little bit risk, but I think there are benefits definitely there, right? So what's the considerations? Manoj, maybe you first.
Sure. Okay. So that's a very good question, actually. So, so there are pros and cons with every technology, and in fact, I famously, I mean, I always say that when it comes to tech, I think the answer to most questions is that it depends, right? So, so there are pros and cons, right? So, so you need to actually ensure and assess that the benefits that you are going to get when you switch to this new technologies, they outweigh the challenges. And challenges will always be there, so you need to definitely have a strategy to mitigate them, right? I mean, my considerations actually include also the in-house expertise and know-how easy it is to move to that solution, and what are the pitfalls, right, that we need to actually be aware of. For example, sharding strategies, right? When we are moving to a sharding architecture, you need to ensure that you have comprehensively studied all the query patterns across the systems, right? One size does not fit all. Maybe you'll need to actually have some kind of custom sharding for some specific use cases. Otherwise, it becomes a broken experiment. And yeah, so I think there is a lot of complexity when you actually go towards any whether distributed SQL or this. So you need to actually assess it accordingly. Know-how expertise is one thing that I want to actually share, and other is also the support that is available. I mean, right? So if there is enterprise support available, that's a good thing. If there is enough community support available in case of open source, that is also a good thing. If there are enough similar use cases and something has been popularly like adopted by multiple companies, that is a good thing, and so on. Yeah.
Thank you. How about Jinru, yourself?
Yes. So when we choose the technical stack, technology stack and products, we want that those technical stack and products to have a better elasticities. So here I share it. Since we are currently a small, relatively small, and we have a relatively small engineering team, and our business is still growing very fast. So we use cloud native applications as much as possible. So because cloud native apps can scale better since they tap into the cloud platform elasticity. So since our business is still growing fast, so this becomes really important to us. Yeah.
Understood. So actually just now.
Sorry, I just
go
want
ahead.
to say plus one to what Jenny just said. I mean, for example, not from transactional perspective.
Manoj.
Yeah, so not from transactional perspective, but from analytics perspective, we have actually kind of focused on keeping the data stack cloud native, right? So more and more going towards managed databases out there, like things like Bigtable and stuff. I think they come very, very handy in terms of like providing the guarantees that you look for and without the operational burden. Yeah.
Yes.
Yeah. So thank you so much, Lishan. Manoj, I think Lishan, I think question to you is like very specific because I'm also curious. Like for TiDB, we also bring a lot of new technologies along the road. It's actually a lot of times very new. Like even we are using Raft for the KV layer, using Kubernetes for the whole architecture. What are that considerations when we want to introduce those to the database?
When we introduce Rust, it's still before 1.0, I think, but we are attracted by its advantage, such as memory management. Yeah, we believe that we should choose the best or the suitable tools for us. Yeah, so we introduce those kind of new tech. For example, another example is that when we choose to integrate with Kubernetes, it's still not at that time. It was not as popular as now. Yeah, at that time, methods and other solutions are also popular. Yeah, but I think we have a good technology view on the new technologies, and it is proof that we make the right choice. Yeah.
Nice. Yeah. Yeah. So we also just heard from like a Square talking about they are using TiDB. One of the reasons like we have the Kubernetes operators for them to easily integrate their cloud native applications. I think that kind of match what the trend are for the industry somehow. So coming back to both of you, Manoj and Jinru, just now we mentioned about sharding already. So because we already talked about the trend, and also you have to consider the sharding and distributed database somehow. But what are the scenarios you are going to use distributed database, for example, and why? or some of the cases I still I think gonna use sharding because of what. So would like you share with the audience on that logic thinking, so that may help the audience understand, and to their own daily work, it may help them too. We can start from Jinru maybe.
Yes. So we're currently using sharding database, but as our business becomes more and more complicated, so we don't the complexity of building this middle layer, the sharding layer, becomes a burden to us. So we want so we are currently looking at to migrate our sharding database to distributed database solutions. That's why we're currently assessing different choices, such as TiDB. Yeah.
Yeah. How about Manoj? Which scenario specifically you think gonna be a good fit for distributed database or for sharding?
Correct. So, so basically at Tokopedia, I mean, we were founded in 2009. So, I mean, we have already like 11-year history, and I think it is similar with every company, right? So you start with certain databases. So in our case, we have certain tech stack when it comes to databases. So we are using Postgres very heavily, MySQL to a certain extent. Mm-hmm. Then on the NoSQL side, I mean, we have Elasticsearch, we have Cassandra, and we have been using Cockroach and so on, right? So the whole point, I mean, coming to your question, how do you decide? So when you are moving so when you're going for sharding, I think your application code does not change as such, right? So you are basically doing the sharding in MySQL or Postgres. You are basically, your application side code remains as it was earlier, right? I mean, of course, there might be some logic changes, but not, I'll say, nuclear changes as such, right? But in case of adopting a distributed SQL, which might be a big investment in terms of changing from application side, but also it comes with a big advantage as well, because it might be something that is more long-term, less of a headache, I mean, in terms of the capabilities that are coming from, say, TiDB and other distributed SQL databases, right? So I think it actually depends on that. For any organization like ours, which is already on, say, some kind of RDBMS heavy investment, I think the first effort is usually to go for sharding, right? I mean, that is a natural choice, right? But I think now with the maturity that has developed in the distributed SQL databases, I think now companies can definitely consider. I mean, it was definitely something very risky a few years back, but might not be as risky as today. I mean, for example, we have tried Cockroach and it has been fairly successful. So yeah, so that is how we decide. Yeah.
Yeah, so just now you mentioned CockroachDB and TiDB. Some of the audience may not understand that database. Just briefly to tell the audience, like CockroachDB is also another distributed database on the market. So we are kind of brothers, where we are boosting the distributed database in the industry. But the big difference are like they are built on top of PostgreSQL, and there's no analytical processing, because there's audience actually asking that question. I think it's also a good time for Lishan to talk about that one, where whether like there's analytical processing in TiDB and how actually we did it. Maybe you can introduce briefly on that.
Yeah. TiDB is at the beginning, we built TiDB to solve the data sharding issues, such as you need to maintain, you need to spend more effort at your application side to shard your data. But at the early stage of TiDB, a lot of users use TiDB as another data warehouse. They think that TiDB can handle more data, and they can use TiDB to analyze, to run their analytical queries. So from the beginning, we got several user requirements for handling complex query. So TiDB is not OLTP only database at the beginning. Yeah. So with each major release in TiDB, we not only improve our performance on the OLTP side, but also we add more features to make the analytical queries better. Yeah. In the latest release, that is 4.0, we add a new feature, which is TiFlash. It's a columnar story engine, can boost the performance of analytical query much faster than the row-based story engine. Yeah. So with that new product, we can make it a hybrid database with a transactional and analytical processing, which can be much better than the past. So we can do some more exciting things like real-time field detection for detection, things like that. So I think TiDB did do a good job on the HTAB category. Yeah.
Nice. So actually, there's audience also asking just now to Square, like whether they're gonna use analytical processing on TiDB too. Actually, I got a answer from Karel, where currently there's no analytics use case for TiDB on their current applications, because they are focusing more on the TP scalability first. But that's definitely something interesting for them, and they really intend to explore that part in the near future. Cool. With that, I think we have 3 more minutes left. I know Manoj is also busy at something else. We do want to also asking you guys. There are mixed audience in the audience currently today. There are new engineers, the engineers coming to work only for a few years, and also VPs. These questions are more for them, the fresh engineers. What are your recommendations for them when it comes to because they haven't really have experience dealing with all these large scaling database and applications? You maybe also have the past experience jumping over from the no experience to currently handling big systems. What are your recommendations to them for them to be better prepared for this in the future when they somehow start to work on these kind of systems? Manoj, maybe you can start.
Yeah. So for people who have to actually make that choice when they do not have much exposure, I will say that my pragmatic suggestion is to stay with what works actually for their scale, their stage of the company, and their technical expertise as well, right? And gradually move towards, solve the problems when they arrive, right? Or do it more proactively. Actually, that's not the right approach. Do it more proactively. Look for, the growth rate and so on, and then see the solutions that you will be needing as you go towards them, right? As simple as thing like sharding or partitioning, I can say call it simple, but it's not simple, right? You have to think about many things. If whether your use case is actually a key range use case, you want to actually search for key ranges, then you need to actually look for key range partitioner, right? Otherwise, maybe hash partitioner might actually work. A document ID partitioner or whatever, right? On what basis are you going to partition? That actually becomes a strategy that you have to decide. And not only that, there are more and more complexities. For example, whenever you have a distributed system and you're partitioning it, obvious question is, how do you rebalance when you add a node or when a node goes down or you remove a node, right? How does the rebalancing happen, right? Rebalancing is a very expensive operations. So as Lishan just mentioned, I think a database are more and more, they are providing solutions for different problems from within the database, right? So you do not have to handle that complexity on the application side. So that is a good thing too, actually. That is a good thing that has happened over time. And I think as they abstracted more and more, my understanding is that these problems, which are very popular or very prevalent in case of, say, sharding and so on, like hotspot and so on. So all those issues will be handled by the database. And even for beginners in future to come, maybe they can start with a distributed SQL right away rather than going to a SQL database. That is what I'm optimistic on. Yeah.
Sure.
Yeah.
Thank you. How about Jinru? Any recommendations, suggestions to the audience?
So my suggestion is pretty simple. So I think it's if you really want to get to know the large scale system, distributed system, just be part of it. Like to join a team and to build and be part of the team to build a system and to solve the real world problem. Because what we talk here is really the experience. We won't discuss the bugs or the challenges in the system. So you really need to get to the real system to get your hands dirty, and you can get the first-hand experience. I think that's the way the people can learn a lot of things, get to know the distributed system fast. Yeah.
Nice. How about Lishan? Any recommendation, advice to the fresh graduates?
My recommendation is simple. For a fresh engineer, I think the most important thing is that align your own career path with a technical trend. Yeah. For example, in the current days, public cloud is very popular, and the database should be run good on public cloud. So that's why we call TiDB the cloud native database. Yeah, so I think the public cloud is a trend.
Mm-hmm. Yeah. Thank you. I think this panel is interesting in a way, like we have mixed with like Manoj, who never heard of TiDB before. Hopefully we are in a discussion with him now for him to try it out. And also we have Jinru, who has been with us for a while, and we have Lishan, who have built the TiDB from the scratch. And also Jinru is actually our TUG APAC ambassador. We are here all gathered because we have this TUG. So Jinru, do you have anything to talk about, share with the community? Like what do you hope TUG can bring to the community, or the community can bring back to TUG? Some word will be helpful.
Yeah, so we want, so one suggestion is that I hope that we can have more meetups in the future, that we have a lot of people here to share their experience on TiDB. So yeah, that would be great.
Thank you, Jinru, for sharing with us. So I know today's session is a little bit packed. We didn't really get to talk a lot of things. We actually have questions from the audience too. We will manage to really answer offline after this session. So as Jinru wish, we are really making the TiDB user group a serious effort, because we have a big presence in Asia Pacific, and we definitely have a planning to bring more audience, the speakers to this panel discussion. And also more importantly, you are free to scan the QR code on your left to join the community, asking any questions you have online or offline. And also we are preparing, because December is a big holiday season. We are not planning any session during this December, but we are planning a big one on January. Hopefully we will bring more interesting topics to you, but we want to hear from you. So what are the interesting topics on you? Because with TiDB's capabilities, we are able to do like real-time analytics, like anti-fraud. We also have seen the customer using chaos engineering tools like Chaos Mesh. And also, if you are interested to be a panel discussion or present some of your technologies, feel free to contact me. We can plan on that. And also, like as what Manoj and Jinru just mentioned, it's really good to try, and also Lishan mentioned, there are TiDB Cloud, there are actually TiDB open source projects where you can just download and give it a try. Feel free to scan on the QR code on your right to start to explore. This will be the last session for this year. So on behalf of TUG, I really wish you a very good holiday season and enjoy the time with, I know a lot of time with the family already, but enjoy the holiday moment with your family. We're gonna see you next year. We will definitely bring you a more exciting topic and knowledge sharing next year. See you next time. everyone. Bye-bye.